Today we're going to be working on the finding roots by graphing review. Hopefully you remember this from last year, but we'll just review a couple things. The first 8 problems ask, is this a polynomial or not? And it's a lot easier to describe what a polynomial is than it is to describe what a polynomial isn't. So a polynomial is an expression where all of the exponents have all of the variables have whole number exponents. So is number 1 a polynomial? Yeah, we usually don't write them that way. The divide 3 looks weird, but look at the exponents on the variables. They're all whole numbers. What about 2? Is that a polynomial? No, why not? They're negative exponents. What about 3? No, we have a variable in the exponent. That's not allowed. Number 4? No, we divided by x. And a variable in the denominator is actually x to the negative 1. And you have to have whole number exponents, not negative exponents. 5? Yes. 6? No, variables in the denominator. 7? Yes. 8? No, x to 3/4 breaks the rule. Okay. Now there are 4 different ways to write a polynomial. And they kind of all mean the same thing, but there are actually differences between them. So the first one is just an expression. Okay, we don't have an equal sign. We don't have a function listed. We don't have a y value. We don't have any of those. So number 9 is called an expression. And an expression is just a mathematical statement. It just says we have x squared minus 3x plus 3. Okay. An expression is not a graph, right? You can't fill out a table. You can't graph it. I mean, we could, I guess, if we added stuff to it. But in its current form, it's just a statement. Number 10 is called an equation because there's an equal sign. And because the equation is equal to y, that means it's a graph. We can graph it. We can fill out a table. We can plug numbers in, right? And that graph specifically looks something like this. Okay. And number 11 is also an equation, but it's a little bit different than the equation on 10. What does that equals 0 do? What's that? Close. It means find the roots. When an equation is equal to 0, that is like a set of instructions that say solve this and figure out where that graph hits the x-axis. So if this is the graph for number 10, then the graph for number 11 looks like this. There really isn't a curve. There are just roots. Okay. And then number 12 is a function. And it's pretty much the same as number 10. You can graph it. You can fill out a table. You can do lots of different things with that. But that is in function form. And there really is very little difference between 10 and 12. But sometimes people look at f of x and think, oh no, what do I do? F of x is just y. Okay? And it represents the whole graph. Okay. Pull out your graphing calculators. If you don't have one, go sit by somebody who does, because you need to make sure you understand how this works. We're going to graph 6 equations that will help us understand will help us understand how to use these calculators. So to begin, number 13, we're going to graph this in our y equals. So you push the very top left button, And whatever's there, just clear it out. And then type in 4x minus 32. The X button is right here next to the green alpha button. And you'll see that it says X, T, theta, or N. There are actually 4 different types of functions we can type in here. And one of them uses X's, one of them uses T's, one of them uses theta, and one of them uses N. The only one we're going to worry about is X. So even though all 4 variables are listed, we'll only ever use X in this class. Okay, so 4x minus 32. And I'm going to push graph, and my graph probably looks different from yours because it's not in the standard window. The standard window goes from -10 to 10 on the X and -10 to 10 on the Y. To get to that standard window, you push zoom, and then number 6 says Z standard. And that will get us to that standard window. Okay. Now, we want to find the zeros. Here's how you don't find the zeros. You don't just take your cursor. Mine's really slow, so we have to push it a whole bunch of times and then wait. You would think that my big fancy computer could run a calculator faster than your little puny calculator, but that's not the case. So why is this a bad idea? It takes a long time on my screen. It's actually a lot faster on your calculator. It's not accurate, right? When I get over to that, all the way over to that point, I'm not going to be exactly on the line. Okay? So don't do it that way. The other way not to do it is to push trace. The difference between what I'm doing right now and trace is the trace requires the point to be on the line. So we're getting there. Moving slowly. Okay, so I push trace, and now you'll notice, if I can ever get there, that, hold on, we're getting there, 24, 23, 22. This is so slow. Okay, in just a second, you'll be able to see the cursor. Here we go. So now I'm stuck on the line, but you'll notice, oh, I'm going to go right past it. Slow down. Stop. See ya. Okay. So that's as close as I can get. And it says 8.03 and 0.12. So that's not where it hits the y-axis or the x-axis. How do I know that I'm not in the right place? The y should be 0, and it's not. So those are the 2 ways you don't find roots. Okay? But the trace button will help. If you think you know what the answer is, then push trace and type in the number you think it is. It looks like it hits at 8. So I type in the number 8, and it tells me 8, 0. Is 8 the root? Yes. So that's the fastest way to find the roots. Push trace, type in the number you think it is. If the y value is 0, then the answer is yes. Now, sometimes the calculator will freak out and will say this: x equals 0, y equals 1.3287 e negative 15. You just freaked out? Sometimes it will do that. What is it saying? It's really close. What is this number? It's 0.0 a whole bunch 14 times 132. Okay, when that happens, the calculator is being more accurate or attempting to be more accurate than it should be. It basically made a mistake. So if you ever see that, it means 8 comma 0. Oh, x was supposed to be 8. There we go. Okay. And also sometimes you'll get this. X equals 7.999999926, y equals 0. Same thing is happening. The calculator is looking at it, and it has something to do with how the calculator rounds decimals. And every once in a while, your calculator will give you something like that. Or it could say 8.0000005. When that happens, just say, calculator, you're not really that smart. Quit trying to work so hard, and then just write 8. Okay? All right. So the next one, number 14, is x squared minus 6x minus 27. So x squared minus 6x minus 27. Push graph. Okay, it appears as though the answers are -3 and 9. So I'm going to push trace and type in -3. That's one of them. And the nice thing is you don't have to push trace again. You can just keep plugging in numbers. So 9, enter, and that's the other root. Okay, any questions about that? Okay, number 15. X squared minus 4x plus 5. Push graph. What are the roots? Okay, we have to be careful. We can't say there are no roots. There are no real roots. Every quadratic has 2 roots, but if the graph misses the x-axis, then the roots are imaginary. And there are ways to find them, but graphing is not really the answer. There actually is a way to find the roots by graphing. It's just kind of complicated, so it's really not worth it. Okay. Next one. Where do we look to do x to the third? So we use the caret button, which is right underneath clear. So x raised to the third, and there are 2 different calculator softwares out there. Mine actually bumps that 3 up into the exponent. If you have that, then you're using the newer software, and the newer software will not need parentheses here in the future. But if you see the little caret button, you need to be more careful with exponents because you'll need parentheses. Not today, but in the future. The bad thing about this is I'm in the exponent, so when I go to type the rest of the equation, oops, it all becomes exponent and drives me nuts. So how do I get out of the exponent? You just push right. Yeah. Okay, so I'm going to type this in. Yeah. So I purposefully missed something. I get down and I realize, oh my goodness, it's supposed to be 2x squared. Well, if I want to jump all the way to the left of my equation, I can push second left. If I want to go all the way to the right, I can push second right. So that'll save you a little bit of time. And I need to put a 2 right here. But what's going to happen when I push 2? It's going to replace the x. So I need a way to insert things without messing up the equation. And to do that, you push second delete, where it says insert. And then when I push 2, it's going to bump the equation over without overriding anything. And that really comes in handy. So you don't have to retype the whole equation. Just move off of it. Yeah. So when it's a solid blinking rectangle, that means you're overriding. When it blinks, but all you see is an underline, that means you're in insert. And you can actually keep typing in insert, and when you finish, you just push right or left, and it'll bump you off of that. Okay, so I push graph, and I have -5, -2, and 5. So let's check those. Trace, -5. Is that a root? Yes. -2, that's a root. And 5, that's a root. Now, what if I wanted to see the hump that's on the left side of this, or the one that's on the right side? What do I need to do? I could zoom out. The trouble with zoom out is it's going to zoom out on the y-axis and on the x-axis. I don't really need to see more of the x-axis. You guys see that? My x-axis is pretty well situated. I just want to change my y-axis. So I'm going to go into Window, and I'll leave my x-axis alone. And for my y-axis, maybe I'll go from -40 to 40. And then, what does this YSCL mean? It's the scale. It wants to know how often should I put one of those little tick marks. So if I'm going from -40 to 40, that's 80 marks. That's probably too much. So maybe I want to count by 5s. And then I push graph. And I captured that side, but I didn't quite grab the other side. So maybe we'll go in here and change my -40 to -100. And then instead of counting by 5s, maybe I'll count by 10s. Oh, I did it. Wonderful. Now, you have to be careful when you look at this graph. The x-axis is counted by 1s, and it goes from -10 to 10. The y-axis is counted by 10s, and it goes from -100 to 40. Now, you don't see that on the graph, but it is inside the window. Okay? Now, let's say I had my x-axis defined from -5 to 5, and well, hold on a second. If you ever want to stop a graph, just push on, and it will pause it, and then you can move on. So -5 to 5, counting by 1s. Okay. So I have this graph, and I say, oh, okay, there is something there, but I don't want to go through the time to figure out what the y values are. If you choose the x-axis, you can ask the calculator to choose the y-axis for you. So I've chosen my x-axis to be from -5 to 5. And then I'm going to tell the calculator, you pick a y value, a set of y values that will capture the entire graph. And you do that by pushing zoom, and then I think it's zoom 0 actually. Zoom fit. And again, in order for zoom fit to work, you choose the x-axis and then do zoom fit, and the graph will choose the y-axis for you. Now, the bad news is it doesn't change the scale. You have to change the scale yourself. But notice it picked a y value that hit the top of the graph, and it also picked a y value that hit the bottom of the graph. So if you know that your x's need to be from, say, 0 to 100, and you don't want to take the time to figure out the y-axis, then set your x and then do zoom fit, and it will pick that window for you. Okay? It will make that window as small as possible to still capture all the points in that graph. Okay? How do I get back to the normal window? Zoom 6. Okay? Number 17, x squared minus 4x minus 18. So x squared minus 4x minus 18. Do graph. What's wrong with this one? It doesn't hit a very nice number. So one thing we can do is to start guessing. The one on the right side looks like it's about 6.8. So trace 6.8. Not big enough. So 6.9. Too big. 6.85. Still too big. 6.81. Oh, was it? Sorry. 6.6. Here we go. 6.7. Oh, that's really close. I'm tired of playing this game, right? We could do this for half an hour before we got all zeros. So instead, we're going to ask the calculator, what is the answer? Now, these calculators aren't very bright, which is weird. They're kind of the industry standard, but the Sharp and Casio calculators are cheaper than these, and they're much better at finding roots than our calculators are, but whatever. This is just what we do. So we have this graph, and the answer is about 6.7, somewhere in there. Okay. In order to find it, the calculator is going to ask us 3 questions. It's going to ask for a left bound, which means pick an x value to the left of your answer. Okay? Now, any number to the left will work as long as it's on the screen. But if you pick a left bound clear over here, then you might accidentally find this root, and your calculator is more likely to make a mistake if your bounds are far from the answer. So you want to pick something relatively close. So 4 would work, 5 would work, 6 would even work. So that will be my left bound. And then you need to pick a right bound, which is somewhere over here. And then you have to pick a guess, which is as close to the answer as you can get. Now, the further your guess is from the answer, the more likely you are to get like 8.000000003. Sometimes that happens, sometimes it doesn't. So push second calc, and then we want to do number 2, which says find the zeros. And left bound, you can just use your cursor. Sorry. So I could just use my cursor and hit enter right there. And my calculator draws a line. The older calculators, they don't. All you see is that little arrow on the top. But the trace buttons are kind of slow. I prefer just typing in a number. So for right bound, I'm going to do 8. And then is my answer between those 2 arrows? Yes, so I did it right. If you get your left bound and your right bound mixed up, your arrows are going to be going in opposite directions, and you're going to get an error. So make sure you do left bound first, right bound second. And then for my answer, I'll do 6.8 for my guess. And I ended up with 6.6904, on and on and on. Okay. Go ahead and do that same method to find the other root. Second calc, 0. I'm going to choose -4 for my left bound, and 1 for my right bound, and then -2.6 for my guess. And I got -2.69. Any questions about that? Okay. So for the last one, I'm going to type in x squared minus 8x minus 240. And then I'm going to graph it. Now, I graphed it and I don't see anything. What does that mean? It's not in the window. So one thing that it might be a good idea to try is just do zoom fit, and then that might give you an idea of where the window is. So zoom and then just push 0. Okay. Look at that x-axis at the top. What do those marks mean? What does that tell you? So those are the marks that represent the x-axis, but do you see how the line is missing? What does it mean when there's no line? We're not actually looking at the x-axis. So whenever you see an axis that has marks but no line, that means you're not looking at the axis itself. Okay? So it did not hit the x-axis in that top left corner. So I need to move my x-axis out. Okay, 10 is not enough. Negative 10 is not enough. And do I need to move it out further on the left or further on the right? Definitely on the right. So I'm going to go into window. Maybe I'll go from negative 15 to, say, 20. And then zoom 0. Did I mess something up? Oh, that's a problem. Negative 15. Zoom 0. Oh, I did it. Okay. Now I see enough that I can do my trace and figure out what those roots are. So zoom fit is quite handy. It really quickly gives you an idea of where you need to go. Okay. Any questions? All right. Get to work.